Today we are doing lesson 5.5, slope. Our I can statements for today: I can find slopes of lines and I can interpret slopes of lines as rates. So slope tells us how steep a line is. And often you hear slope in terms of hills or stairs describe how steep something is, how difficult it is for you to walk up the hill or walk up the stairs. When we are doing slope for a line, we're going to start with our stairs and we're going to measure two things called rise and run. Rise is how far up for each step, and run is how far over for each step. So if we start by looking at these stairs here, for each one, we go up 2, 1, 2, and over 3. Same thing here, up 2, over 3, up 2, over 3. So our rise, how far up, is 2. How far over is 3. And slope you write as a ratio. That looks like a fraction. It looks like 2/3, but it doesn't really mean 2 out of 3. It means up 2 over 3. Just like fractions or ratios, we do need to make sure that our answers are in simplest form. However, we will not have any mixed numbers unless it is a story problem situation. All right, let's take a look at this next one. Our rise, we're going up 2, and our run is over 2. Same thing for this one, up 2, over 2. So our slope we write is 2 over 2, and that does simplify to one whole. You can have a slope that's a whole number. You cannot have a slope that is a mixed number. Okay. Let's go ahead and try this one. So for number 3, we go up 1 over 2. Up 1 over 2, up 1 over 2, all the way across. That means our rise is 1, our run is 2, and our slope is going to be 1 over 2, 1/2. So now that we have practiced finding slope for stairs, we're going to apply that into our line. So for finding our slope, the first step is to turn your line into stairs. You're going to pick 2 points on your line. It doesn't matter which points. You're going to do a little stair. You can do it in your head or you can actually draw it out. Then you're going to measure the rise, how far up, and the run, how far over. And then you'll write your slope as rise over run. So here on this line, I've got up 1 over 2. Our rise is 1. Our run is 2. Our slope is going to be 1 over 2, or 1/2. Let's try this one. We can pick any 2 points that we want. I'm going to pick these 2. My rise is 1. My run is 3. Slope is rise over run, so 1/3. If I had picked different points, let's say I picked these, the beginning and the end, whoa. I would have gone up 3, and I would have gone over 1, 2, 3, 4, 5, 6, 7, 8, 9. And I could have written it as 3/9, and that still would have simplified to 1/3. We always want to make sure slope is in simplest form. Okay, let's try this for C. I'm going to pick these 2 points. Run is 2. I'm sorry, rise is 2. Run is 2. So our slope is 2 over 2, which simplifies to 1. You can have a whole number for your slope. You cannot have a mixed number. All right, so here's your key idea. Slope is the rate of change between any 2 points on a line. It is a measure of the steepness of a line. To find the slope of a line, find the ratio of change in y, the vertical change, to the change in x, the horizontal change. So rise over run. There are 4 different types of slope. So all the lines that we've seen so far have positive slope. As they go from left to right, it looks like they're going up. You find your rise and your run, and then you put rise over run, and then you simplify if you need to. Negative slope looks like this, where it's going down. If you think of a capital N, that negative slope is going the same direction as the slant on a capital N. If you can add lines to the side of your diagonal line and make it look like a capital N, then you have negative slope. And when we calculate that one the same way, we count rise and run, but we put a negative in front of it because really our run is going down. Here I'm going down 2 and over 2. All right. If I have 0 slope, that's flat like the floor. It does not go up at all. There is no rise. The 0 is your rise. On this one, the run is 4. It goes over 4. That simplifies to 0. You can think about a z, turning that z into our 0 slope. And then undefined, that line goes straight up and down. If you think about a U, that side of the U goes straight up and down. That's undefined. There's no slope at all. It is literally straight up and down. You can't really climb that if you're walking up the stairs if it's completely straight up and down. So that's undefined. Okay, so let's go ahead and practice a little bit more for finding our slope. So here they're giving me the coordinates for 2 points. They have it connected and labeled here for you. Again, you can always draw your own step. I usually draw mine on the top. Doesn't really matter. We count our rise, 1, 2, 3, 4. We count our run, 1, 2, 3. And then we write a ratio, rise over run, 4 over 3. I am not doing 1 and 1/2. I need to be able to see my 2 parts. If it becomes a whole number, like let's say it's just simplified to 1 whole, I know a whole number is always that number over 1, so it's very easy to see the 2 parts. But if I have it as a mixed number, it's no longer easy to see the 2 parts for the rise and the run. All right, let's take a look at B. So here I'm going up 3, I'm going over 6. They already did the counting for me. I do need to simplify that to 1/2. Again, slope always needs to be in simplest form. Now they did give you ordered pairs next to it. So I'm going to show you can do subtraction to find your slope as well, depending on the picture and the numbers. Sometimes it's easier to use the subtraction. So I'm just going to go back and kind of show you how you would do it if you wanted to use that strategy. When your graphs are going up by 1s, which both of these are, then it's pretty easy to count boxes. But when it goes up by something else, sometimes it's easier to do the subtraction. So for slope, here's your formula. y2 minus y1 divided by x2 minus x1. Remember, an ordered pair is x first and then y. So if we're looking at our ordered pair, I'm going to call this pair number 2, and I'm going to call this one number 1. You start with 1, and it doesn't really matter which one. X comes first, and then y. And you would set up your subtraction. I'll do it down here. My y is the second one, 4. And my x is the first one, 3. And then I subtract my x and y from the other point. This happens to both be 0. 4 minus 0 is 4. 3 minus 0 is 3. 4/3. If I was going to do my subtraction over here, let's see, I'm going to call this one x1, y1, x2, y2. Okay. Y's go on the top. 1 over 4. Always have to start with the same point. And then you subtract your second numbers. These are both -2. 1 minus -2. 4 minus -2. Boom, 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 boom. I end up getting 3 over 6, which simplifies to 1/2. So you don't have to use this slope formula. Some people like to use the subtraction instead of counting, and depending on how your graph looks, sometimes the subtraction is going to be the easiest way to find your changes in your rise and your run. But I'm just showing it to you as an option for your graph or for your slope. All right, here are 2 for you to try on your own. So go ahead and pause the video and try these 2. Okay, let's go ahead and check our answers. I'm going to go ahead and draw in my little step here. My x and y axis are going up by 1, so I can count. 1, 2 is my rise. 1, 2, 3, 4, 5 is my run. So 2 over 5, that can't be simplified. All right, now let me look at this one. This one's trickier. And the reason it's trickier is on this side, on the y-axis, it's going by 2's. So I can't just say it's going up a box and a half and over 1. I've got to actually pay attention to how much it's going up by. So for this one, I am going to use the subtraction. On my y-axis here, I'm starting at 5 and I'm going up to 8. So I'm going to do 8 minus 5. And then on the bottom here, I'm going to do 2 minus 1 because I wrote 8 first here. So I'm going to write 2 here. Okay, so this was my x2, y2, x1, y1. 8 minus 5 is 3. I went up 3 numbers from 5 up to 8. That's going up 3 in value. Even though it wasn't 3 boxes, I'm still going up 3 in value. And then over here, I'm going from 1 to 2, so that's over 1. And then 3 over 1 simplifies to 3. All right, let's take a look at a story problem situation. The table shows your earnings for babysitting. A says graph the data, and then B says find and interpret the slope of the line through the point. So I actually have 3 things to do. I have to graph, I have to find the slope, and then interpret means explain. I need to explain what it means. So when we are doing a graph for a story problem situation, we need some labels. I'm going to go ahead and just put earnings for babysitting. That's what this information is about. I get that from here, earnings for babysitting. It tells me the X, which is my horizontal axis, is going to be hours. So I'm going to go ahead and draw in my x-axis here. I'm going to label it hours. It tells me my y, which is my vertical axis, is earnings in dollars. So I'm going to label that one dollars. Okay, now I need some numbers and I need to go consistent in value. I don't have to go up by ones, but I do need to make sure it's consistent. Okay, so let's see. It looks like I'm going up to 10. Those are going by 2's. That's consistent, so I'll keep that. I'm going to skip every other line and then write my number. Each time I skip 1, 2 squares, made my number. 1, 2 more squares, made my number. Okay, over here, I'm going up by 10s. That's consistent as well. So I'm going to skip 2 lines and then write my 10s. 10, 20, 30, 40, 50. On this one, because my table happened to be going up by consistent things, I could use those numbers. Sometimes you'll have to use numbers that are not on your table. Okay, now I'm going to do my points. 0, 0, 2, 10. 4, 20, 6, 30, 8, 40, 10, 50. I'm going to connect my line. I'm going to extend it, put an arrow on the end. This is a proportional graph. I know it's proportional because it's a straight line. It goes through 0, 0. Okay, I did A. That's my graph. Now I need to find and interpret the slope. I'm going to pick 2 points. I'm going to use 0, 0 and 10, 2 as my slope. You can pick any 2 points that you want. I can't count my boxes and say up 2 over 2, my slope is 2 over 2. Because my going with my boxes, they're not going by ones. So I have to think about the value. Here I'm going from 0 to 10. That's going up 10. It looks like 2 boxes, but really with numbers, it's going up 10. And then over here, I'm going from 0 to 2. That is 2. That's going to simplify to 5 over 1, which is 5. I divided by 2 on both parts of my ratio to get 5 as my slope. Interpret. That means explain. So for this one, the explanation is you earn $5 per hour for babysitting. Okay, here are 2 more for you to try on your own. Go ahead and pause the video and try them. Okay, let's check our answer. So example 2, 2 other points. I'm going to pick these last 2. 8, 40, 10, 50. So these are the 2 points that I picked. I'm going to use the subtraction. 50 and 10 I'm going to use first. Y's go on top. 50 minus 40 equals 10. 10 minus 8 equals 2. 10 over 2 equals 5. Does our slope change? No. All right. Compare the steepness of the lines. This is me and my friend. What does this mean? So the steeper line is this blue one, which is my friend's. My friend's is steeper. What does that mean? My friend makes more money per hour. All right, and then find and interpret the slope of the blue line. Okay, I'm going to use 0, 0 because that is a nice, easy point to do my subtraction with. And then 428. So on my y, my rise, I'm going from 0 to 28. That's going up 28. And then on my run, I'm going from 0 to 4. That's going over 4. 28 divided by 4 equals $7 per hour. That's what my friend makes. All right, let's take a look at how you would do these if you have some fractions or decimals. So graph the line that passes through each pair of points and then find the slope. Since I have some negative numbers in here, when I'm setting up my graph, I do need to do a 4-quadrant graph. When you are making graphs of your own, we would like you to do them on graph paper. You can always print that out if you need to. All right, let's see. I'm going up to 4.5. I think I'm just going to go by ones. 1, 2, 3, -1, -2, -3, and then here I'm going to go by 2s. Actually, no, I'll go by 1s, but 1 every line. 1, 2, 3, 4, 5, -1, -2, -3. Okay. All right, so now I'm ready to plot my points. -2, -3, over -2, down to where -3 is, make a point. 3, 4.5. So over 3 up to where 4.5 would be. That's going to be halfway in between 4 and 5. Connect those with a straight line. Arrows on the ends extend that line through the graph space. All right, I'm going to connect my points to find my slope. All right, so let's see. I start at -3 and I'm going up to 4.5. So it's like 4.5 minus -3. If I do boom, boom, that gives me 7.5. I'm going up 7.5. And then from side to side, I'm going from -2 over to +3. I used this point first in my subtraction below, so I'm going to do that point first again. 3 minus -2. Boom, boom. It's going to give me 5. So I have 7.5 over 5. Now, that's not going to be a simplest form fraction because I have a decimal in a fraction. So when I have a decimal and a fraction that I need to simplify, I'm going to do the same thing that I do when I do decimal division, which is to move that decimal one place over, add placeholder zeros if needed. So now I have 75 over 50. So now I no longer have a fraction in my, or I'm sorry, I no longer have a decimal, 75 over 50. But I do still need to simplify it. And I can do that by dividing by 25. So 75 divided by 25 is 3. 50 divided by 25 is 2. 3 over 2, I'm not going to make it a mixed number unless it's a story problem situation. So 3/2 is my slope on this one. All right, now I'm going to set up my graph for this next one. It looks like I have fractions. Oh, holy moly. Did not do a very good job of drawing that straight. I'm going to try a little bit. A little bit better there. Okay. So now I'm going to go ahead. I'm going to number these by fourths. 1/4. 2/4 would be 1/2. 3/4. -1/4, -1/2, -3/4, 1/4, 1/2, 3/4, -1/4, -1/2. Okay. All right, so now I'm ready to plot my points. -1/4 over -1/4 up 1/2 is right here. And then 3/4 -1/2, so over 3/4 and then down -1/2. This time I have a negative slope. See how it goes down from left to right? So that means when I write my answer, I'm going to make sure I have a negative with it. My graph isn't going by ones, so I do need to, can't just count boxes. Okay, so I'm going to use subtraction to help me on this one. Actually, I'm just going to kind of think about it. I am going to use subtraction, but I'm going to kind of think about it as I go. Okay, so I'm going to do my rise. I'm starting at -1/2. I'm going up to +1/2. So this would be a 1/2. And this would be another 1/2. So that's like going up 1. And really, because I know it's a negative slope, I'm going to go down. I'm going to make it a negative. And then over here, I'm going from -1/4 to 3/4. So over 1/4, 2/4, 3/4, 4/4. That's like going over a total of 1. So -1 over 1 is like -1. All right, go ahead and pause the video. Try these two on your own. Okay, let's go ahead and check our answers on these. So let me get my graph set up here. Okay. Your X and Y numbers don't have to go up consistently. So here I did 1s for every 2 spaces. Here I did 1s for every 1 space, just based on the numbers I knew I'd need. -1, -4, over -1 down to -4 would be right here. 3 -4 over 3 down to -4. That is going to be a 0 slope. That line is flat like the floor. All right. And for my last one here, All right, so let's see. -2, 1.5. So over to -2, up 1 1/2 would be right here. And then -2 down, -2.5 would be right here. Connect with a line. That is going to be undefined.